Welcome back. It's Damon, known as Crazy Logics, Crazy Logics 007 on YouTube. Uh, when last we were at this amp, uh, it was the drive had gone crazy for the power supply. It had gotten real wonky, and was having trouble figuring it out. It's kind of had me flummoxed. Said, "Screw it, go to sleep on it." Excuse me, and. So I shut off the recording and I published that video up so you guys could see that I can't figure out everything right off the bat either. And so sometimes the best thing to do is just stop and take a break. So right after that, I thought, really what I ought to do is strip that stuff out and start from square one. And square one would be, you get power from the remote. It goes through the circuitry to turn on the chip, the TL494 pulse width modulation chip. That goes out to the drive transistors, then that goes out to the FETs. And so that's what I did. I went ahead and pulled all the FETs, which you've seen me do in the last video. If you haven't, go ahead and watch that. And then I pulled the drive transistors out here. Now I'd looked those drive transistors up and knew I was going to, if any of them were bad, I was going to have to replace them. And so I'd got some of my replacement transistors, which are actually a little bigger and a little nicer. Sorry, my computer's dinging at me. I must be getting some notifications. Anyway, I'd looked those up and made sure the pinout was the same and the specs were close enough, and it kept saying it was a PNP, and it didn't click with me what might be wrong there. So anyway, let's power this up and bring the scope up here, and let's see exactly what we're getting coming out of the chip. Okay, so it comes out of the chip that's on this board. I traced it out, and it goes to each one of these. Not only does it go to the base of all these transistors, but it goes here to the positive side of these diodes, these little rectifiers. So if we go to fire it up, you're going to see the green light come on. And man, that's an ugly drive circuit. Let's check all of them. They're all pretty fugly. That's not good. And that equates to a really fugly drive circuit out here. So that should be nice and square coming out of that chip, and it's not. And the thing is that normally the chips don't get hurt. Our power light's coming on, which, if you notice, this power LED's got 3 legs. That's just 2 regular LEDs where they've built it with 2 of the legs soldered together. If I can, they've soldered 2 of these legs together. They put positive on one side, negative on the other, and then depending on what you drive on the common middle leg, if you drive it high, it'll light up one LED. If you drive it low, it lights up the other LED. So that's what that does. It'll light up red if it's in protect. And to test LEDs, the cheap little like 2032 batteries you can get, these are really low current, so they won't pop an LED as long as you do it quick. But if you've got LEDs that you can't remember which side's negative and positive, this is the positive side of a coin cell, this is the negative, you can stick them on there to figure out which side. It really helps if somebody's cut it off, if it doesn't have a good identifier, if you're just going through and testing, oh, that's not it, and bam. Real handy. These don't require a resistor in line with the LED because they just don't deliver enough current to pop it, as long as you're doing it fairly fast and you're not going to leave it sitting on there. So it's a great way to test LEDs. That's how that dual LED works. So we get remote signal come in, it turns the chip on, the chip starts producing pulses. They look terrible. It does do good enough that there's not a fault somewhere else, that it's turning on the green light, even with no power supply FETs in and no drive circuit. So we know we got a pretty ugly square wave, and so I tested all these resistors in here, and let's kill the power. All the resistors in here and the diodes with my diode checker. Now we could get really technical and pull each leg or one leg up of all this on everything that's on that drive circuit, so that there's not a chance of anything on that drive circuit pulling it. But I got this funny feeling that it's this chip, and the reason why is because those are PNP transistors. So let me explain how normally power supplies work. Normally, you know, you'll turn on the remote that goes to the little chip, and you're going to get to see the chip because we're going to have to pull this board. And that chip will feed out to, for each parallel pair of transistors, power supply transistors is going to turn on. It'll normally, in a lot of amps, it'll feed to a PNP and an NPN transistor. And they'll be set up as an emitter follower. And so what will happen is the chip will turn one of these on, and that will turn the FETs on. And when the chip turns it off, by going off, it actually turns on this PNP transistor. And the PNP transistor just connects the FET down to pull it down. And what that does is that helps give you that nice sharp square wave. And if you don't pull it down really quick, it can have that jagged edge like we've seen. And so some amplifiers don't do that. They stick with just an NPN transistor to turn the power supply FET on, that will be right here, and they use a resistor to act as the pull down instead of a PNP transistor. And so, you know, it took me you know, thinking about it and taking a little rest and a little break when it finally dawned on me that these were PNP transistors, not NPNs. So that means these resistors were not acting as any kind of pull down to pull those FETs down. So actually what this amp looks to be doing, from what I can tell, is the driver chip actually drives through this, there's 4, these FETs, to turn on this pair and this pair and this pair and this pair of power supply transistors, so we can get our flip-flop here and our flip-flop here and make our AC, and that'll come out here and then get rectified and smoothed with these caps for our rail voltage for the outputs. And so it's like, so this chip is basically directly driving those FETs. Well, that chip is very current limited. That's normally why you put the other transistors in there. But they're using this PNP transistors that were in here to pull that back down really fast to keep that square. And the reason why you want that square is if you don't have it very square, you have to increase your dead time, which is the gap between when this top wave, if this is your stuff, when your top wave forms and when your bottom wave forms, if this is 0 volts. And if this is all angled, you have to move your next square wave to start later, and so that's going to be dead time. And the better you square those up, the closer you can get those to where they're almost perfect, and you get more efficiency out of your transformer because you're flip-flopping as best you can with almost 0 dead time in between the transitions between positive and negative. So anyway, it looks to me like we have an ugly wave coming out of there. So we're going to see about taking that chip out, putting a new one in, then we'll give it a test, and if that fixes that wave, shazam, we're good. We know that we can then put the transistors back in and the FETs back in and then give it a test. So we'll focus on getting this thing going in a good looking wave. If all that works, I probably won't tape sticking all the stuff back in. I'll stick one in of each for the first test, and then put them all in there. We'll see if that all works, add the sound piece, and then we can run a tiny bit of test music through so nothing heats up, just at super, super low volume. If that all works, we know everything's good. We'll double check it. Remember, we have to repair a trace under on this one, and we're going to inspect all of them real good. And then we can, once it's tested and it's good, it'll be, you know, I've got some of these caps on order. I don't know how soon they'll get here, but I'll try to do the little final test once I've got those and swapped them out. I will take some of these out in this video or the next, just so you can see how I do it, because part of them are hooked to a ground plane and stuff like that, and so they're a little bit more difficult to take out. So try to give you some pointers on that. So let's go ahead and flip this bad boy over, and you can see here is where that board goes through. So the first thing we're going to do is we're going to add some leaded solder. Make that a little easier to melt off there. Get that all good and mixed in there. That just helps lower the melting point of that solder. Get in here. Let's try the old solder bulb. Not sure if it's going to give us. Let's try this. It's getting some of it out. We're probably just going to have to do some solder wicking. Trying to get that wick right up against that other board so it pulls all the solder that we can. And we take our iron that's cleaned off, run it across there. Hopefully it'll pull the solder away. It looks like there's a little more in there. That looks pretty good. Let's go ahead and nip this off. Work on the back side here. Oh, when you get old, you don't have the dexterity you did when you were young. A lot of solder there. Go back through and give it another go. Would you believe I've tried to pick this amp as a simple power supply repair to help introduce people into it. That looks pretty good. I'm gonna give that a little wiggle. That looks pretty good. Right there. Looks pretty good. We don't want to pull off any pads, so if it's not moving, re-desolder it. What I'm looking for is to make sure that, yeah, I see one that's connected. So you're looking to see if the pads are moving free or if they're fighting, or you've got a little solder. Okay, we're wiggling pretty good there. I don't see why she wouldn't come out. All right. So if you look, get a little, clean this up just a little. Notice all our solder pads are good there. All our solder pads are good here. That's just taking your time to clean up all that solder so that you can wiggle that sucker back out and make sure it's disconnected from those two pads. All right. So now we got a little bitty board to work on. See if I can get you guys a little closer in. So we got this little bitty sucker to do, so I'm going to fire up my smaller soldering iron. There's two different chips on here. If I bring this up close, I've got autofocus off. Let me see if I can. Maybe turn it on there, see if it'll focus now. Yeah. Sorta. There we go. Oh, it did it for a second. Come on, focus, you flip, like certain other people say. So there it is. It's TL494. We're going to be taking that sucker off there. I don't think I can zoom anymore. No, it's not letting me zoom anymore. Alright, so here's how I do it. Get my soldering iron going over there. It's heating up. I'm going to need one of these little chips. Right there. So, get some kind of focus on there. Yeah. See, it's got a line on this end. Sometimes they'll have dots. That line's telling you that this pin over here in the corner is pin number 1. That is the same on this one. There we go. See, there's that line. Oh man, I hate it when it won't focus. Focus, you dang thing. Goober. There we go. See the line? Yep. You have to see it for a quick second. So just like taking out anything else, first we're going to add a wee bit of, and where is my cheater glasses? Because I'm old and crap and need them. Well, I got this pair up here. It's not my favorite pair. I'm not sure where I set the other ones down. Normally they're right here in front of me. Maybe I need glasses to see my glasses. Alright, so anyway, got my cheater glasses. These are like times 2 or 3. Cheap from Walmart, a few bucks. So, let me get a little solder on the soldering iron. I'm just going to go to each one of these legs and get a wee bit of solder on it and get it mixed in with the old solder. And the whole point and the whole purpose is to lower that melting point of the lead-free solder by combining that all up. Alright. Now that we've done that, we're going to take the hot air rework station, our hot air gun. We're going to slowly heat up the whole board a bit. I've got mine set to about 380 degrees Celsius. I could change it to Fahrenheit, but I haven't bothered. You just find a setting that works and say screw it. So we just want to warm the whole general board. If you just focus really hard and intense, sometimes you can stress and crack the board because of thermal expansion. So we just give it a nice pre-warming so everything's a little more even. Then we're going to focus a little harder. Now you can get a smaller tip than this, and I have it. We're going to go from side to side right along those legs. I don't have the iron or the air force too high. But since this one's supposed to be bad, we don't mind heating the chip itself too awfully much. So we're just going to try to keep it there. And suddenly it'll get liquid. Since I can't zoom in very well on this, you didn't see the solder get liquid. There you can kind of see it. And all of a sudden then I knew, hey, it's time to pull it. So this is a suspected bad. Anytime I have suspected bad, I put a dot of silver on those little black chips or stuff. That way I can't get it confused. So we'll set that out of the way. Now we're going to get our desoldering flux here. We're going to clean this up. Where those go? Now, if you're ever having trouble with getting things on or off, add flux. It's just amazing what a tiny little bit of flux, watch this, can do. It's already melting because we got that hot. especially on cleanup. Now, flux is what you don't want to breathe. That's what makes most all the smoke. Sorry, I was holding my breath. That's why I have my little. Little fume extractor. It's just a little fan set up with carbon filter elements. And if I'm going to be doing a bunch of soldering where I can't, just kind of hold my breath, I will fire it up, and that way I can do all that soldering, and it'll suck it up and it'll catch all those fumes from all the flux and everything. I got one little resistor that got a little sideways here. You have to watch that. I don't know if you can see. Let's see if we can. This is not too hot to hold. It can happen. See that resistor right at the top? See if I can point to it. Right there, got a little sideways and off its pad. So I think I can just touch that up. It's not wanting to go where I want it to go. Add a little tiny drop of flux. A little bug. A little bit of flux. This is where your old people specs come in real handy. It's hard to do with a soldering iron. Come here, you little twerp. That's a tiny, tiny little resistor. Once you get one end, you can spin it around. Now you can do that with your hot air. That should get it. We'll blow on it a little. I don't know if my fat bald head's showing up in the picture. I think I've got the camera zoomed in good enough that it shouldn't be. So now we got pretty looking. See if it'll autofocus. Man, better quality cameras would help. Now that's fixed, and you see how those pads are all nice and perfect? So I'm going to pick an easy to get to pad with my soldering iron on one of the ends, and we're going to add just a touch of solder to it. We're going to make a little pool of solder on it. See if we can, yep, see that little pool of solder? And that way, we bring this one in. It's going to set flat on all those pads. Okay? Except for the one with our little bit of solder. If I can get a hold of it. There we go. And we're going to use the soldering iron to solder that one leg and get this thing flat. And nice and lined up. Looks pretty good. Now we're going to pick the opposite side here and just add a touch of solder. Let that settle down just a minute. Make sure this other side's good. And just let it set for a second. So now that chip is flat because we only did one side and got that chip down where that little hump was. Soldered another side so that chip ain't going to move, ain't going to go bye-bye. And now we're going to add a little flux. The reason why we add flux when we want to do this, the flux will make that solder flow just to the pads and just to the pins. Really, really nice. And you don't have to have a hot air rework station to put it back on. So using my specs, and get a little solder on here. And basically what that's going to do is keep solder bridges from happening. If you've ever tried to solder these little suckers, you know that solder bridges happen. With that flux on there, you can just kind of wick at it a couple times and it'll get rid of all the bridges. And you dang near can just move the iron along and it will just solder up all the connections for you. Really, really nice. Just like that. Clean the flux off the board. When I clean anything, 99% of the time I use isopropyl alcohol, which is 91% or better. I probably said that. But that does the majority of my cleaning because it's cheap. If I got something blown up, and we're going to have a blown up amp here, pretty charred with soot and stuff, after I get done, you'll notice isopropyl alcohol won't clean everything perfectly, and then I'll go back with acetone and clean that all up. Now to cheat, to get that to really dry off, I'll take my hot air gun and kind of just blow it from afar, get some hot air running over that. That makes that alcohol evaporate real quick. Plus it ensures that that little tiny bit of water, you know, it's 9% water, also dries up and goes away. And that's where the downside of isopropyl alcohol is. If you're using a lot of it, you'll notice sometimes it leaves the tiniest of slight white residue. And that is the evaporation of the water on there with whatever contaminants was with it. So we're at about 30 minutes. I'll try to hurry up here. We need to go back into the board. We've got our nice chip here. Did I show you the nice solder joint? It's on that. I don't know that I did. That's the beauty of using the flux and dragging that across there. No bridges. Everything looks fantastic. I'm going to snap that sucker back in. Flip her over. Make sure she's in there good. Get our soldering iron with a little solder. And we're going to do just kind of like we did with the chip. We're just going to bridge up here one of these solder pads, and that should hold it in place. And then we're going to get another one on the other side, on the other end. One little bitty joint's not enough. There, all of a sudden that's nice and tight. I pushed up so it was in place real well, and now we don't have to worry about that sucker wiggling and dropping out. And we can get to soldering. Now these are nice and big. I don't think I'll have to have any flux. I do not like this design at all, and I'll tell you why. Because it is using pure solder basically for the joint, and solder is not as good as copper. You know, the best conductor is silver, followed extremely closely by copper, you know, standard conductor. After that it goes, I think, aluminum, then, or no, gold next after that, then aluminum, then lead, I believe. So you can see that lead and tin's even lower than that. So your solder is not near as good as a copper trace or a copper pad connection. And so I do not like this design for that reason, that they're wanting to make this connection purely with solder. It's doable, you know, it's all low power. It's not like it's handling big current or nothing. It's just the drive signal stuff, but not my favorite. I'd rather seen pins going through viers so that it could get a good touch. And all that, you'll hear me breathing out to blow away any smoke that starts to accumulate. And hold my breath some here as it gets closer to my face. So, looks like we got all that done. So, anywho's, that should be in. Here it is, moment of truth. We will let that cool off for a minute. And then we will recenter this a little better for you. I'm going to, off camera, also finish cleaning these all up, all the stuff. If we get good signal, we'll end the video here. I'll go ahead and start replacing end components because then we know we've fixed that part. And once this cooled down just a skosh, let's go ahead and put some power there. Test blip it real quick. Alright, the green light came on. That's a good sign. Let's grab our scope probe and see if we solved the problem. Let's bring the scope up. There it is. See a little light pop on. Oh, look, it is not nearly as crazy. I think we have found our problem, boys and girls. So now we have a much better looking wave. Let's go ahead and go scope focus. And I don't know if you remember the other one, but it was super angled, super crazy. This one now just has the standard little ringing, meaning that it does not have stuff in there. Notice the top gets good and flat. It distorts a little, but it looks a whole lot more square than the other one. That and it was of the let's go to that, and it wasn't way up there with an angle. Let's see if we can back up here a little now to get a little more of that. Change back to this. Oh, you guys are wobbling. So now I think we got a proper drive signal, and the other thing I think is that this chip, since it had got damaged when this short happened on this FET, since that's driven directly by this chip, I think it damaged this circuit, and then when it was trying to drive anything, it just was falling on its face. I got a funny feeling with a fresh chip in here that's not internally damaged, it'll be able to drive the transistors. So we're going to end this here. We've got a much better looking signal. I'll take the time, off camera to go ahead and do some soldering here. I will save this one, or at least put it at the beginning as the last one to do, because this is the one with the broken trace, and I want to show you how I repair that with some of this and make it nice and neat. And make it better than what it ever was. So I want to include that, and then we'll show this thing running. I may hold off till tomorrow. I got to check. These caps may be coming in, so if they do, that'd be fantastic. We can show the repair here. We can show how to remove these caps from the ground plane. Oh, we got out of focus somehow. I wanted to focus. There we go. Let's turn that off now. We show how to remove on the ground plane. Get that all finished up. We'll run a signal, especially if we got brand new caps on here. Then I don't mind. We can drop it back in the heat sink and actually clamp it back down. Put some real tunes to it. Put the Formica insulators with fresh thermal paste and stuff. So probably hold off at least a day. Try to see if I can get those parts in real quick. And that way we can show this thing rocking and producing a little music. Once you kind of get it there, you get it all buttoned up. Then you go, anyway, threw my glasses away. I've got load resistors. Let's try to get this under the camera. big old load resistors, and I learned that you have to stack them up. This is a temporary setup off your piece of wood, because it's not on this piece of wood, but I got another piece of wood that's got a big old burn mark in it from this. But this is a 1,000 watt 4 ohm. You can see that, and so I use it. Now it doesn't pull 1,000 watts out of your amplifier. It can handle 1,000 watts, and it's 4 ohm static load. I always do a quick test. Make sure I'm getting good audio from all the channels, good sound out, nothing looks bad, checking with the O-scope. Get it bolted all down and stuff. Then I'll put that load resistor on and give it as much as I can give it without clipping. I'll use the O-scope to check for clipping. Get everything good and hot and make sure some component wasn't weak and it isn't going to fail. Do that on all the channels. Then finish buttoning up the amp, put it back on speakers and listen for sound quality. Make sure there's no little distortion or something like that in there. But normally you catch that the first time. Like I said, I do audio quality check with it out, really low volume, just to make sure it's playing. Power, put it through the power resistor, get everything good and hot, make sure nothing has a bad joint or is going to fail real quick. And then after a good burn-in test for 10 minutes or so on each channel, we button it all up, do a little sound quality playing, and she's repaired. So thanks for watching. I hope you learned a little bit. Hopefully this last one will show some great stuff too. I'm kind of excited about it. And hit subscribe. Tell your mom, tell your friends, tell your enemies, everybody like that. If they want to learn a little bit, I'll try to go over more stuff. And we'll do some other things besides amplifiers. I've got some PlayStation controllers and stuff I got to repair. So there'll be all kinds of fun stuff, but we'll get it done. So save some money by fixing some things yourself if you're interested in learning this kind of thing. Like I said, I hope you learned something, and I'll see you next time. Thanks. Bye.